If you've already covered differentiation, you would have come across the power rule. Now, this is different than the product rule, and we're going to talk about the product rule in a minute, but the power rule helps us find the derivative of simple polynomial equations. So, for example, if we have an equation like y equals x to the power of n, where n is a real number, then the gradient of this function, or the derivative, is found by multiplying all the x terms, so the single x term in this case, by their power and then subtracting the power by 1. So for example, if we have a polynomial with two x terms in it, y equals x cubed plus 2x, to find the derivative using the power rule, would look at the first x term, multiply the power of that term by any coefficients in front of that x term, then subtract the power by 1. And we'll do this with the second x term and any following x terms after this, giving us x to the power of 0. And x, or anything to the power of 0, is always equal to 1. So our derivative for this polynomial equation, for this cubic equation, is 3x squared plus 2. Okay, so we've covered the power rule. What about the product rule? So the product rule helps us find the derivative of more complex functions. So for example, like these two here. Now these types of equations can be written in the form of y equals u multiplied by v, where u and v are both functions of x. So if we have a look at equation 1 here, if we were to write this equation in the form of y equals uv, we can set u equal to x squared minus 1, and we can set v to x cubed plus 3, which is the second bracket here. But in order to find the derivative of y equals uv, we need to use the product rule. And the product rule, dy over dx, is equal to u dv dx plus v du dx. Now this equation would normally need to be memorized for most courses, and you're expected to know this in order to answer these types of questions. So let's try and solve these two equations above using the product rule. And we're going to start with equation 1. And we've already split it up into its u and v components. So you notice here with the product rule is that we need to find the derivatives of the u and v equations here. So u equals x squared minus 1. We need to find the derivative of that with respect to x. And v equals x cubed plus 3. We need to find the derivative of v with respect to x. So using the power rule, where we multiply the power by any coefficients in front of the x term and subtract the power by 1, du over dx is equal to 2x, and dv over dx is equal to 3x squared. So if we have a look back at our product rule, we can see now that we've got all the terms that we need to find the derivative of the original equation above equation 1. And we can plug these values into this equation. So we know u is equal to x squared minus 1, and we're multiplying that by the derivative of v with respect to x, which is 3x squared. Then we add v, which then we add the term v, which is x cubed plus 3, and multiply it by the derivative of du over dx, which is 2x. So we need to simplify this and find some common factors. So if I multiply out these brackets here, x squared multiplied by 3x squared is 3x to the power of 4. We also multiply -1 by 3x squared. When we multiply out the second half of the equation, we've got x cubed multiplied by 2x. So we've got 2x to the power of 4. And then we've got 3 multiplied by 2x, which is 6x. Now we've got two common terms here, which are 3x to the power of 4 and 2x to the power of 4. So if we sum those together, we get 5x to the power of 4 minus 3x squared plus 6x. And to simplify this further, we can factor out an x term. We can factor out a power of x. So we put x outside of the brackets here, and we multiply it by 5x cubed minus 3x plus 6. And that's our derivative for the first equation. So let's try the second equation. And the first thing we need to do for these types of equations is to write out the product rule. Now, again, you need to memorize this for exams in most courses. So, can you remember what the product rule is? So if we start off with dy over dx, and that's equal to so we have u multiplied by dv over dx plus v over du over dx. The next thing we need to do is figure out how we can represent this equation in the form of y equals uv. So what's our u and v going to equal to for our second equation above? Well, we can set u equal to 20x, and we can set v equal to x minus 1 to the power of 6. Now, we come to a bit of a problem here with v, because we can't simply use the power rule to solve the derivative for this equation, because the power rule only applies directly to expressions where the base is just x. But with v, the equation v, we have a composite function. Now this simply means we have a function within a function. So we've got now a power function raised to 6 and an inner function which is x minus 1. Now with v, we could use binomial expansion to separate out all the x terms and then use the power rule on each of the x terms, or we could use the chain rule to find the derivative of v equals x to the minus 1 to the power of 6. Now the chain rule in this example is quicker to do and will lead to fewer mistakes. So we can write out the chain rule like this, and again you'll most likely need to memorize this type of equation. So dy over dx is equal to dy over du multiplied by du over dx. Now the u in this example is different to the u above. In this equation, with the chain rule here, we're assuming that y is equal to x minus 1 to the power of 6. So we're substituting in y for v. And now we're setting u to equal x minus 1 for this example here, for the chain rule. So we got y is equal to u to the power of 6. So we can use the power rule directly to find the derivative of u to the power of 6. So dy du, so dy over du is equal to 6u to the power of 5. Now we need to find the derivative of u is equal to x minus 1. Now this is simply 1. So if we have a look at our chain rule, we've got the value for dy over du, and we've got the value for du over dx for this equation. And we just plug in the values. So we've got dy over dx is equal to 6u to the power of 5 multiplied by 1. And this gives us, when we expand everything out, 6 open bracket x minus 1 close bracket to the power of 5. So if we go back to our equation previously, where v is equal to x minus 1 to the power of 6, we've just found the derivative of this equation using the chain rule. And the derivative of v with respect to x is 6 open bracket x minus 1 close bracket to the power of 5. Okay, so we got step 1 out of the way. Now we need to have a look at the equation u is equal to 20x. Now we can simply use the power rule to find the derivative of this equation. So du over dx is equal to 20. So we got the value of u, we got the value of v, and we got the derivatives of both these equations. Now using the product rule, we can finally find out what the derivative is for y is equal to 20x multiplied by x minus 1 to the power of 6. So if we plug in our values, we've got 20x, which is u, multiplied by the gradient or the derivative of our equation v, which is 6 open bracket x minus 1 to the power of 5 to the power of 5, plus our equation for v, which is x minus 1 to the power of 6, multiplied by the derivative of the equation 20x, which is 20. Now, if we multiply all of this out, our goal here is to find some common factor so we can simplify this as much as possible. So the 20 here, I'm going to separate that away from the x and multiply it by the x minus 1 to the power of 5, and then multiply it by 6x, because everything here in this first term is multiplied together. So you can rearrange the variables and the coefficients here. And with the second term, after the addition sign, we've got x minus 1 to the power of 6. I'm going to remove one of the powers of x minus 1, leaving us with x minus 1 to the power of 5, and I'm going to multiply that by 20. And what we're doing here is trying to isolate a common factor, which in this case is 20 multiplied by x minus 1 to the power of 5. And we can move this term outside of some brackets here, and we end up with 20 multiplied by x minus 1 to the power of 5, open square bracket, x minus 1 plus 6x, close square bracket, and then we can simplify this down to this final term here, 20 multiplied by x minus 1 to the power of 5, multiplied by 7x minus 1. And that's the derivative of the second equation here. And that's just a couple of examples of how to use the product rule in differentiation.